Welcome back to all of our market rebels and all of you on YouTube. And we have almost an emergency type of coach's corner here, Stu. We've been getting so many questions about time decay from people. And it seems like a lot of retail traders feel like the entire reason for doing any type of option strategy is to guard against theta and watch out for the steep part of the time decay curve and only sell options so that you have positive theta. Well, as we've always said, avoiding theta is easy. Just don't trade. There's got to be more to the story than just this whole idea of negative theta. So thought it'd be kind of a good topic for us.
Bill, are you trying to say that there's some connection between like maybe the VIX and extrinsic values and theta and all that kind of stuff?
A very big connection.
Is that why we're getting all these questions? Like, what should I do about this theta curve? And
yep.
It's just never ending.
We're getting those. So yeah, so let's take a look at it. And we're going to start off with our usual chalk talk question. We'll come back and answer it at the end. But let's just say that an option has 40 days to expiration. And the question is, where is the steep part of the time decay curve? So for anybody who's been trading options, will certainly know what I'm referring to. We'll look at some examples here, but there's a part where you really visually start to go off a cliff. And there's a formula, we'll look at it, and it's going to say it's right about this spot, and people say that's where you have to be careful. And the thing what we want to do today is to challenge that and say, is that really correct? Is that really the steep part of the time decay curve? So hold that thought with that question. Let's get this thing started here, Stu. So our topic, obvious, are you on the dangerous part of the time decay slope? So let's start off with
actually say what is the danger? I would start with that if I was asking somebody like.
Well, we talked about we should probably back up before that theta really isn't even a risk. We always tell traders it's a characteristic. It's just because it's an expiring asset. Because if you see it as a risk, then you have to realize that risk is always defined as uncertainty. And time moves in one direction at one speed. So we know in 30 days will have passed.
We do know that.
We can absolutely predict it with 100% certainty. It's one of the few things we can predict in the markets with 100% certainty. So how can it possibly be a risk? See, we have to look at it in a different light and say it's just part of having an asset that is going to expire.
And to sum that up, I would just say, if you really want to get head over heels and consider it a risk, that means there must be some reward on the other side.
And right? And that's a very good point too.
It's got to have, if it's a danger to you, if there's something that you can lose on it, what's the upside? Why, what's the tail? What can you gain from having data?
Yeah, we were just talking about it in Q&A today. If it were an absolute danger where nobody wanted to touch it, you would have no market for options because everybody would want to be a seller. There has to be a reason that some people are buying.
Yeah. All right.
So why are those people willing to accept time decay? So anyway, lots of things to talk about. Now, before we get started, especially for our new people, there's another connection with options and prices. For at-the-money options only, that's important. And it's called a square root pricing principle or a rule. And it comes about because volatility is proportional to the square root of time, and option prices are proportional to volatility. So therefore they have this kind of weird square root pricing relationship. So let's start with that and it'll make more sense about these curves. So let's just say we're looking at our broker's platform here, Stu. We see a 1-month option trading for $1. And the question is, what's the 4-month option trading for? Now, most traders would say how much?
4 times.
Yeah, you got 4 times as much time. That's obvious.
1 month, 2 months, double the time, double the price.
Right. And like so many things in options, what seems obvious is not true. Yeah. This is a perfect case. So here's the way we figure it out. We do have 4 times the amount of time. I made this work out nice and neat here, but in the real world, take the second option here divided by the first, and you're going to get some factor. In this case, it's exactly 4. And you'll take the square root of that. So the square root of 4 is just saying what number times itself equals, in this case, 4. 2. And that tells us the answer. It tells us that this relationship over on the right-hand side will be a factor of 2, not a factor of 4.
Yeah, super
So
important.
this should be trading for about $2. In the real world, is it going to trade for exactly 2? Pricing model, it will, assuming we don't have interest rates. But we can have skews and typically do in the market, so don't be flipped out if you think, oh, it's not exactly working out in my broker's platform. It will be close.
And also assuming it's a straight line of implied volatility.
Exactly. That's why I said with the
Might
skews.
have a tilt going
Yep.
either way.
Lots of things. But remember, if it were too far out of line, a calendar spread will bring it back in line. So we know that they're going to be roughly in this relationship. So just for another example, if the 1-month option were trading for 3, multiply it by 2, the 4-month option would be trading for 6. But notice it's not because there's 4 times as much time. I'm sorry, not because there's 2 times as much time. There's 4 times as much time, and therefore it's got twice the value. So another little talking point here for people who are new, all things equal, you should lean towards buying longer dated options because they're cheaper per unit of time. If we take 6 divided by 4 months, that's $1.50 per month on average. Whereas if you take $3 divided by 1 month, that's $3 per month. It's exactly twice as much. See, it looks like half as much because people would say, well, 3 is half of 6. The 1 month is cheaper. And it's not cheaper per unit of time.
But hold on, Bill. I read in a book somewhere that it said that I should sell weekly options instead of a monthly option.
And then you hear that too. People say that, well, I should sell the shorter term options, all things equal. You don't want to sell a short term weekly 10 points out of the money for 5 cents. Because you say, well, now what's the point? We have no downside hedge.
Yeah.
So there's always lots and lots of things to consider.
There's lots of variables, right? And I can make an argument for either side, and I can make
Oh, sure, you could. Yeah,
not to do either side. I can always make both sides of that. And
course.
we actually did a coach's corner on just that. Maybe we should revisit
did.
that at some point.
Not a bad thought.
Yeah.
So now with this little background, let's find out more about this dangerous part of the time decay curve. Before we do, quick little, as Mark says, a shameless plug for us here, marketrebellion.com/get started. Lots of great information just like this. We have articles, videos, all kinds of things right there to help you understand options and make better decisions. So let's now take a look at a time decay curve. Now, once again, I'm going to keep hammering this point. Whenever you see this, this is usually what you see in books and websites when they talk about time decay. And it's really unfortunate because out of all of the options on the board, there's probably one, maybe a couple, if they're near the money, that this applies to. But technically, it's only one. If the stock is 100, it's the 100 strike. Everything else is on a little different curve. And if as you go further out or further in the money, those curves get radically different. So that's the first thing to understand. Don't forget it. When we're talking about the time decay curve for today, it is for at the money options. So
are you trying to tell me that if I have an out of the money option, it's not going to fall off the cliff like that?
Exactly right. It will, but the cliff is actually on this side. And then it tends to level off. I know, kind of weird, backwards.
Yeah.
So let's take a look. What we have is an option trading for 10. That's the vertical scale. And over here, I've got 100 days to expiration. I did this just to make the math a little easier. But because of this square root pricing relationship, after the first 75% of the time has passed, you will lose 50% of your value. Or we could also say when 25% remains. That's the way I always like to teach it, because when we look at the square root pricing relationship, it's always about how much time is on the option. And that's going to be part of a clue of where we're going today. It doesn't matter what it used to be.
No.
The option doesn't know that 75% has decayed away. It just says there's 25 days till expiration. And so when we hit this part, when 25% of the time remains, guess how much you're going to lose after that? The second 50%. So now you can see why a lot of traders get concerned with this without thinking about it further. They'll say, gee, I get kind of this free ride, not much time decay. And then as soon as I hit this 25% mark, bang, I go off this cliff. And so what I need to do is to roll my option or close it because we don't want to be on the dangerous part of the time decay curve. Now, again, this is up for debate, but we're going to find out that the 25% mark has some interesting properties to it, and that's why I like to focus on it. But the main point is it's somewhere down here that traders are going to start telling you that you need to take some kind of action because of theta. All right, so that's the kind of the premise. So let's do a little simpler example. Let's say we have 40 days to expiration, and traders will look at this and they'll say, well, it's a fairly shallow, relatively speaking, curve through here, kind of get into a gray zone through here, and then we go off this cliff. And so again, this is what's causing the concern for people is that they go off this cliff. So let's look at the average rate of decay. What's our average rate here, Stu? We know that options don't decay in a straight line, right?
We do
see
know
it.
that. We do know
We
that.
can see it. It's a curved. It's fairly shallow and then bang off this slope. But there's nothing wrong with saying what is the average rate of decay. So I could say if we have 40 days of time that we're going to lose $4, we're going to take 4 divided by 40 is 10 cents per day on average.
On average, very important.
On average, right. Do not say it decays 10 cents each and every day. That is not true.
No.
But on average, it's true because we have to start at 4 and end with a value of 0 across 40 days. So on average, it's 10 cents per day. And what happens when we get to this 25% mark?
Wait, hold on. Time out. Quick time out. So everybody that's watching, start thinking to yourself, well, if that's an average, like some's going to be below and some's going to be above. And where does that start kind of meet? Yep. Think about it as Bill's talking about.
We're going to look at that. That's a very good point. So let's look at this 25% mark. And because of the square root pricing relationship, what do you suppose happens to our options price? Well, it's going to go from 4, and look at that, gets cut exactly in half, which makes sense. We said that 50% decayed in the first 75% of the time, and then the second 50% in the second half. Now, we can go back to our square root relationship, and we can say the square root of 25%, remember, it's how much time remains, is a half, and that's going to tell us what it's going to do to our options price. It's going to retain half of its value, and that'll work for any point on the line. Okay, just convert it to a percentage, take the square root, and that'll tell you what's going to happen to your option price. So one way that we can visualize this is that we can look at this average decay in blue. And for those who have had calculus will recognize this from the scary days. We're going to look at what's called a tangent line. We're just going to slide this thing out until it just touches some point on the curve. And that's going to be at the 25% mark. And when that happens, the options theta will exactly equal the average rate of decay. So back when we saw this, I could say, well, 40 days, we're going to lose $40. That's 10 cents a day. I know when 10 days remains, or 25%, the options theta will also be 10.
Bill, I have a question.
Sure.
I know that I had calculus. Was it calculus that you just said?
Yeah.
Yeah, I know that I had that. But I can't really remember what I learned in calculus. Does that make me old?
No, just means that you were you're normal. Nobody can remember what they learned in calculus.
And I skipped school and went to buy donuts that day.
Yep, but that's where this is coming from. All right, so there we could put this into a formula, take the first derivative, all kinds of things. We can find out that's exactly where it's going to line up at 25%. So a nice little visual that I like to do with traders is to think about that we're looking at the side view of a mountain, or two mountains here. We're going to put a snow skier here and one guy in the blue slope. Now remember, the guy on blue is on the average slope. The guy in the black slope is on the true time decay slope. So which one of these snow skiers, Stu, is going to be skiing faster in this region? Not through the whole range, but just up into here.
The top guy.
Top guy, he's on a steeper slope.
Yeah.
So that tells us that the average rate of decay is greater than the options decay, or that the options decay less than average. And that's going to be true all the way down to this mark.
Mm-hmm.
Now what happens on this, kind of what you were just talking about, what happens on this side?
Now you're going slower.
Now they flip. Exactly. The option is going to decay faster and the average rate is going to be slower. So the option decays faster than average. And so that's why I like to focus on this 25% point. Again, it's kind of up for debate as to where you want to say the steep part of the time decay curve is. But I think that's a nice, just visual, kind of mathematically appealing, lots of neat things we can do with the numbers. So again, a lot of traders would say, oh, you got to do something, you got to bail. Here's our point, everyone. We can look at that and we can say, yep, you're on the steep part of the time decay curve. No argument, we got to do something. Well, how did we get here? What are we comparing that to? The reason that you're saying we're on the steep part of the time decay curve is that you're looking left and saying we used to have 40 days, we used to be up here. All right, so of course that makes sense. That's when we bought the option. That's our starting point. So this now becomes the critical exit point. Hold that thought. If we're allowed to look left, then when you bought this option with 40 days and thought you were on the safe spot because this is where you were starting, why can't we look left here and say, well, you know, Stu, yeah, you just bought this with 40 days, but this option used to have 160 days to expiration.
Yeah.
And so let's look left. We're making that's 4 times 40. And our option is going to do what? Double, 4 times the amount of time. Now where's the dangerous part? All right, we've got 160 days. Where's the danger part now? Right at the part that you said was safe. And then people say, well, hold on a second. You can't look left and say, well, it used to have 160 days. I just bought it with 40 days. Well, then my argument is that's exactly what you just did when we were at 10 days.
Yeah.
You looked left and said, well, that's what it used to be. See, so you have to say, well, what gives? Where are you? Is it okay to say that let's look left and say where it used to be? And like so many things in trading, it comes down to it doesn't matter what you paid for it or when you bought it. The option doesn't know how many days it used to have.
Or what your cost basis
Or what your
is.
option doesn't know what you paid for it. It's whatever it's just really going to help you to make decisions. What you're looking at is what you see is what you get. Right now, if I were trading this option, I'd say I have a 40-day option. I don't care that it used to be 160 and say, well, therefore I'm on the dangerous part. It's because I could easily say that it used to be 160 or 640 was 4 times more than that. And now 160 is on the dangerous part. We can always make any point in time the dangerous part of the curve. We have to say, what do you have now? Right? In Philadelphia, it's how much, Stu?
$50.
For those who don't remember, that's from the Trading Places line when, who was it? Dan Aykroyd went to the pawn shop with that expensive watch and they've been arguing what was it, $6,000 or something?
$69.95. Yep.
Oh, is that what it is? He says in Philadelphia, it's $50. And I just remember laughing so much at that because I thought that's so much like markets. Doesn't matter what you paid for it.
Bill, you know who the I meant to talk to you about this today. Forgot. Do you know who the pawnbroker was in that scene? Like in real life?
Oh, you know what? I think I did. Wasn't he a musician of some kind?
Yeah. Bo Diddy.
Oh, that is Bo. Okay, I thought I'd forgotten that until you said that.
Yeah, pretty cool.
Very cool.
Yeah, yeah.
So anyway, I think that's the important message to take is that what you see is what you get. Don't say, well, it used to have 40 days, so therefore 10 days is the danger zone. Because I can just as easily say, well, it used to have 160. And then traders come back and say, well, yeah, but I bought it when it had 40 days. It doesn't matter. The option doesn't know. So now let's come back to 40 days. You know, these same traders will say you're only allowed to look right. I bought it with 40 days. We're looking right because time that's the way we visualize time moving. Time moves right, so therefore 10 days is the dangerous part. Well, if that's true, and you're saying, okay, here's where I started with my 40-day option, and I moved down here, I'm allowed to look right. Well, hold on a second. Then if we have 10 days till expiration and you're up here, why can't I look right and say that the steep part of the time decay curve is when 2.5 days remain?
So the answer is, people, you can.
You
Right?
can, you're always,
Right.
the point is that you're always on
Some part of the
some
curve.
part of the time decay curve, and we can make it whatever point you want by
You're,
making a comparison left or right.
you're on some part of the curve
Right. And the
according
curve
to what
doesn't
is
know.
left of the option, not where
Right.
it came from, but what is, you got to move forward, right?
Right.
It's
And you
what
have
is.
to just say, this is what I have. Right. I could still say, well, it's a 2.5 day option, and therefore take a quarter of that and say, we would get, I could make this now. We know that that's going to be a $1 option. I could cross this out and make that one and make a new 25% mark. It's fractal. We can keep drilling down. If we went to where we had 2 hours until expiration, instead of putting days down here, we could put hours or minutes. We would get exactly the same curve. Exactly. Why? Because it's based on this square root pricing rule. That's exactly what this curve is right there. So that's how we know that will always work. Now, with that, let's pull up a pricing model and take a look at some things that you should really consider instead of, or at least just not only theta. So before we do that, quick reminder, marketrebellion.com/get started. And with that, Stu, I'm going to bring up Mr. Pricing Model here. Now, this is from barchart.com. I'm going to put a $100 stock price, 100 strike, 40 days to expiration, and I'm going to make this 30.3, kind of this odd sounding volatility, so we get exactly a $4 option. All right, try this at home, pick whatever numbers you want. Now, take a look at the theta. Theta is 0.05. And so if we go from
Hold on, Bill. It's 0.04996.
That's a good math question, but 0.04999 is the same as 0.05.
Yeah. Yeah. Don't
And
try and make this like a scientific, no deviation at all. It's close.
It's
Close enough.
0.05.
It's close enough.
But now,
And
watch
by the
what
way,
happens.
everyone, see how Bill put the volatility 30.3? I don't think that he made that because it happens to fit the equation. He didn't do that. He made it to make the math easy on the other side to make
over here.
price
Sure.
exactly 4. That's it. That's all it is.
Yeah. And actually, I probably could have changed this to get that. That could still stay at 4, and we could probably get that to come up to exactly 5. But at any rate,
but none of it matters, because
if I go to 25% of the time remaining, what should happen to my theta? Well, remember, we're going to say the average rate of decay is how much? 10 cents. And we also know that that's where the options price gets cut in half. That's another way to understand my theta should do what? Double.
Remember,
so now
it's
we have another way to,
and it's 40 days. That's where he got the 10 cents from.
Yep. So now we've got another way to figure out the current theta. If you say that there's 40 days and it's a $4 option, I know that the average theta is 10. I know that the current must be 0.05. So watch this. Let's say a fourth of 40, 10. That's what we looked at on the example. This should go to 0.10. And there we go. And the options price goes to 2. So did the options price get cut in half? Yes, it did. Did theta double? Yes, it did. However, let's go back and look at something else. Lots of things are changing here. Look at my gamma. My gamma is about 0.04. And if I go back to this 25% mark, what's going to happen to my gamma? It's going to double. So watch this. Let's go back to 10. Now we're at 0.08. So this is exactly why it's dead wrong when people say you've got to do something because you're on the dangerous part of the time decay curve. What if we were trying to maximize gamma? This is exactly what we want. We'd want the 10-day option, right? If we're after gamma, let's say for a UOA trade, unusual options activity, I would much rather have a gamma of 0.08 than out here at 40 days with 0.04. That's why it's wrong to say, oh, yeah, but your theta's twice as big. No, it's a characteristic of an option. They are all tools. It depends on what you're trying to do. So we can see that that's always going to be true.
And see, this the whole gamma thing. You know that we get that a lot in our Q&As, right?
Oh, yeah.
That's about that for that UOA type of trade where you're looking for swift moves in a short period of time. That's what you want.
Oh, for sure.
You want that gamma, right? You can go to the same strike 6 months out. You're not going to get anywhere near that kind of movement in the change of the delta. That gamma is going to be, much lower. But if you're, which will give you more money that you're paying for the time, and it'll give you lower decay. If you're looking for lower decay, that's what you're going to get. But you're going to give up your gamma, right? You're going to give up your.
Again, if somebody says, "Oh, you're at the dangerous part of the time decay curve," you need to roll out to 160 days. Let's go out 4 times as much. All right. Yes. Watch this. Your theta is going to drop in half. Your options price is going to double, but your gamma is going to also get chopped in half. So watch this. Let's go. So remember, $4, 4 gamma, and 5 theta. And there we go. We have an $8 option. We have
times
0.02 or 2.5. That was 5 before. And then what's our gamma? 0.02. Gamma got chopped. See, now if I go to 640, 4 times as much, what's my options price going to be? 16. So we go to 640. See, now it's a $16 option. And our gamma's going to, look at our gamma now.
It's like it doesn't even exist,
It's
right?
just getting crushed. Now, yes, it's true that your theta is low, but look at your gamma. So why is it right to say that I want low theta, but somebody else who comes along and says I want high gamma, that suddenly is wrong? If you're after high gamma and a quick explosive move, then yes, you'd much rather be here, even though you've got a higher theta.
It just means that there's more to the option than meets the eye, and that you got to know
exactly
in order to have what you believe to be some sort of edge. You got to understand the product.
Yeah,
right?
Everybody thinks that options are about direction, just up or down. That's all I need to know.
No, that's always stock.
It's always stock. But you hear it in the conversations. What do you think? What's going to happen to the stock? Is it going up or down? Well, there's a lot more we need to ask than just up or down, but that's all they focus on.
Yeah.
And so because of that, they say, well, let me buy a call. Now that we know, or at least strongly believe that the stock is going up, let me buy a call, which is not necessarily a good idea because we have to account for gamma and vega and other things. But they'll buy a call and then they say, well, that's why I have to focus on theta. Maybe. But what if the trade was really about gamma? See, and now they miss it. Trade goes against them, and then they say it's because of the market makers.
Yeah, I hate those guys. It's so funny. Like you and I may agree. You and I being just retail newbies, and we may agree. What do you think the stock is going to do, Bill? I think it's going up. Stu, what do you think the stock is going to do? Well, I think it's going up. And you say, okay, well, I'm going to buy this option, and I say, okay, good, I'll sell it to you.
Yeah,
right? We both had the direction in the same manner. Right. What's going on here? Like I'm looking at things that Bill may not be looking at,
right,
or vice versa.
One wants positive gamma, one wants negative gamma.
Right.
There's a lot of different things we have to consider.
Yeah. Which are not that difficult to understand. You just have to know that they're there and look at them.
Yeah. So anyway, I think that's probably the main points that we wanted to make.
Yeah.
And so again, it's just to show that things are never what meets the eye when it comes to options. There's always another side, which is why Stu and I will at least almost always tell you it depends. No matter what your question is, I can't ever think of other than something like your extrinsic value will be at 0 at expiration. Okay, yes, that's going to be for sure. But there's very few things for sure because it does depend on what we're trying to do and what our assumptions are. Are we assuming volatility is going to stay the same? What are the assumptions? So now with that, let's go back to our chalk talk. Option has 40 days to expiration. Where is the steep part of the time decay curve? A somewhat knowledgeable options trader might say, I know it was somewhere around the 25% mark. I'm going to say 10 days. But now you see why that can't really be true, because they're looking right, saying time's moving forward towards the 10-day mark. Why can't I look left and say it's 160 days and 40 days is the dangerous part? The better way to understand it is that whatever time you have is what you've got.
In this
It
case,
doesn't matter
40
when you
days and
bought it, what it was, correct.
25% would be 10 days.
Yeah. But
Right?
then we
And
could
then
continue. If that trader wants to make the argument that you're only
20
allowed to look
days is
right,
5 days, and
then
10 days
let's
is
look
2.5.
forward and say it's 2.5 days is going to
Yeah.
be the dangerous part.
Fractal. Fractal.
That's right. You can always keep going 25%.
Yeah.
Yep. So anyway, we hope that at least gives you some things to think about. Probably not going to hear that in other places because everybody is so bent.
And by the way,
trading it.
one quick comment, that 25%, that's the mathematical reality of everything. In real life, practical terms, there are other factors. We mentioned that earlier.
Oh, sure.
There's vol tilts, there's vol skews, there's changes in price, there's in the money, out of the money, you know, all that kind of stuff. So all those things have an effect. But again, we were just focusing solely on time, all else being equal.
That's right. Yep. So just to show that these can be slippery slopes, not because you're on the slippery part of the slope, but because it's very hard to say exactly where it is.
Mm-hmm.
So we want to thank everybody for joining us. We again hope
Yeah.
that you picked up a few good tidbits. That's what it's always about. And for all of our Q&A people, I'm sure you'll recognize parts of these discussions, but certainly bring them back to us next week and we can talk more about it. But Stu, thanks for being here. We got to get Scotty on again soon, or Greg, somebody.
You do have to get Scotty on
Yeah,
here.
we got to get those guys back on here. So maybe we'll reach out to them and have them on next week. But until then, have a great upcoming weekend, and we'll see you next Thursday for Coach's Corner.